Okay, so the other part of molar mass that we want to talk about involves the molar masses of compounds. And really, it doesn't really matter if the compound is covalent or ionic. The way we're going to calculate the molar mass of that compound is by using the same method. So essentially, here's the guide to calculating molar mass. Step one, obtain the molar mass of each element. Again, where do we get that from? We get that information from the mass number rounded to 2 decimals in the periodic table. Then you're going to multiply each molar mass by the number of moles of that element in the chemical formula. And we know for a chemical formula, the subscripts not only tell us in terms of counting individually, but they also allow us to count by the mole. So the chemical formulas, whether it's an ionic or a covalent compound, allow us, it tells us the number of moles of each atom, covalent, or moles of each ion, if ionic. So we'll take the molar mass and multiply it by the subscript in the chemical formula, and we'll do that for each element. And then we'll calculate the molar mass by adding the results, by adding the masses, essentially the contributions of each element to the overall molar mass. Okay, so let's take a look at an example. Have the compound C2H6O. How would we calculate the molar mass? So we use the periodic table, and for carbon, we find that 1 mole of carbon is 12.01 grams. For hydrogen, 1 mole of hydrogen is equal to 1.01 grams. And then 1 mole of oxygen is equal to 16.00 grams. So those are the molar masses we would have to ascertain from the periodic table. I just happen to know them because I use these 3 elements to talk about them most all the time. But if you go to the periodic table, which you have a copy of it, you can even see it here. If you take a look at carbon, hydrogen, and oxygen, these are the molar masses that we're going to be using. So carbon, based on the chemical formula of C2H6O, there would be 2 moles of carbon atoms. Each mole, has a molar mass of 12.01 grams. So its contribution to the overall molar mass of the compound is 24.02 grams. Okay. Hydrogen. Based on the chemical formula, there are 6 moles of hydrogen atoms in C2H6O. Each mole of hydrogen has a molar mass of 1.01 grams. So its contribution to the overall molar mass is 6.06 grams. And then for oxygen, based on the chemical formula, there would be 1 mole of oxygen atoms. Each mole of oxygen has the mass of 16 grams. So its contribution to the overall molar mass would be 16 grams. So what we did was we took the chemical formula and the individual molar masses for the elements, and we found out how much they contribute to the overall molar mass by using the subscripts, which indicate the number of moles. The final thing I'm going to do now is I'm going to add the results. So I get 8 and 0 point, 4 and 6 is 10, 16, carry the 1, 3, 4, I get 46.08 grams is equal to 1 mole. 32, 42, 46.08 grams is, next time I'll use the calculator. 46.08 grams is equal to 1 mole. And here, because we're talking about a covalent compound, essentially 1 mole of C2H6O molecules would have a mass of 46.08 grams. Okay. Now again, just like we saw with elements, these molar masses can actually be used as conversion factors. Again, to convert between what? To convert between grams and moles. So in the next couple slides to finish off, we're going to take a look at a couple of examples of that. What the added step essentially in these problems as compared to what we saw in the previous video and earlier on in the module when you're dealing with the molar mass of elements is that when you're dealing with converting of grams to moles with compounds, you actually have to calculate the molar mass first, which I guess in our case is a good thing because it gives us more practice in doing that. So here's an example where we're going to convert mass to moles of an ionic compound, sodium chloride. So a box of table salt, sodium chloride, contains 737 grams of sodium chloride. How many moles of NaCl are in the box? Okay. So periodic table, 1 mole of sodium would be equal to 22.99 grams. 1 mole of chlorine would be equal to 35.45 grams. And again, we just go back and double check that. So sodium 22.99, chlorine 35.45. Okay, so those are where they would be. So for sodium, based on the chemical formula, there would be 1 mole of sodium ions. The 1 mole of sodium ions would have a mass of 22.99 grams. So its contribution to the overall molar mass here is 22.99 grams. For chlorine, based on the chemical formula, there would be 1 mole of Cl- or chloride ions. Each mole essentially would have a molar mass of 35.45 grams. And I forgot to put in the grams with the other ones, so let me put that in. So its overall contribution to the molar mass is 35.45 grams. So then we're going to add up those two numbers. (22.99) plus 35.45, and for sodium chloride, 58.44 grams would be equal to 1 mole. And essentially here, because we're dealing with an ionic compound, we would have essentially 1 mole of NaCl formula units. So essentially 1 mole of sodium chloride formula units would have a mass of 58.44 grams. In solving the problem, that part of it is not that important. That's why I put it in parentheses. But because this is the first, we're sort of dealing with an ionic compound with this, I wanted to make that distinction for you. Okay. So we go back to the question, and the question tells us that we have 737 grams of sodium chloride. So now we're going to multiply that by a conversion factor using the molar mass. And in our answer, we're looking for a certain number of moles. So what's going to go where? 1 mole is going to go in the numerator, and 58.44 grams is going to go in the denominator. Why? Because when I multiply, I want the grams to cancel. So in terms of the numbers, we're going to divide 737 by 58.44. And when I put that into my calculator, I got 12.61 moles of sodium chloride. Okay. So that's one example. The other example, now we're going to take a number of moles and convert that to mass. So the question here is how many grams are in 0.150 moles of iron 3 nitrate. All right. So 1 mole of iron is equal to 55.85 grams. 1 mole of nitrogen is equal to 14.01 grams. And 1 mole of oxygen is equal to 16.00 grams. Again, these are the molar masses from the periodic table. Okay. And let's go back and just double check. So iron 55.85, nitrogen 14.01, oxygen again 16. Okay. So for iron, based on the chemical formula, there's going to be 1 mole of Fe3 plus ions, essentially here. So we'll take 1 and multiply that by 55.85 grams. And its contribution to the overall molar mass is 55.85 grams. Okay. So for nitrogen, the chemical formula tells us that there are 3 moles of nitrate ions, which have NO3 parentheses 3. So the chemical formula tells us that there are 3 moles of nitrate ions. Within that, how many moles of nitrogen would you have? Well, for every nitrate ion in the formula NO3, there's 1 mole of nitrogen. So since we have NO3 3 times, we're going to have 3 moles of nitrogen. In this case, if you wanted to refer to that as nitrogen atoms, that would absolutely be okay. Times 14.01 grams. So its contribution to the overall molar mass is 42.03 grams. And then finally, oxygen. So again, there are 3 moles of nitrate ions. Each nitrate ion has 3 oxygen atoms. So if you have 3 moles of nitrate ions, each one having 3 oxygen atoms, 3 plus 3 plus 3, or 3 times 3 is 9. So we have 9 moles of oxygen. Again, if you wanted to say atoms, that would be perfectly fine. So we're going to do 9 times 16, and we come up with a value of 144 grams. So when I put that into my calculator, 42.03 plus 55.85, that gives me a molar mass of 241.88 grams, which would be equal to 1 mole. In this case, again, 1 mole of what? It would be 1 mole of iron 3 nitrate formula units. Again, formula units because we're dealing with an ionic compound. So in the question, we're given 0.150 moles of the iron 3 nitrate. We're going to multiply that using the molar mass of the iron 3 nitrate as a conversion factor. And this time, we're looking for a number of grams. So in this example, I'm going to put the 241.88 grams in the numerator, and I'm going to put the 1 mole in the denominator. And I'm just going to erase this grams and move it a little bit. Let's just move it over here. So in this case, I'm going to multiply the 0.150 times 241.88. And when I come up with that, I get a number of grams of 36.28. So 0.15 moles of iron 3 nitrate formula units would give a mass of 36.28 grams. And your homework questions will give you practice in terms of elements and compounds, not only calculating molar mass, but converting between grams and moles.